Good morning, guys. So here is your video for today. Just want to make sure everybody's all right and touch base with kind of where we're at with the quiz that we just took and moving forward from there. So first off, if we're looking at the quiz, a couple things. If you turn that in, great. If you didn't get that in, have probably 7 or 8 people from this class that's not turned it in. So get that in. If you turn it in, I got that graded. The only thing that I really noticed that we want to make sure that we do on the next one is that you're showing your process for every question. Don't just throw me an answer on there because you can get that a million different places, right? I need to see your process, what you were thinking on each problem. Now, I was pretty lenient on that as I graded those this time, but next time I'll kind of be looking for that a little more. So make sure you are showing your process that you're using to get to your answer. The second thing is next one, and we'll talk about this a little bit later too, is everybody's going to submit theirs through Google Classroom. I know probably 65 to 70% of students did, and it's just a lot easier for me to organize that and make sure I know whose I have and whose I do not have. So all assignments and quizzes will be submitted through Google Classroom, which you do it the same exact way. For those of you that emailed me, you just take a picture of your work, and instead of emailing me, you just go into Google Classroom and you turn in the assignment, and you do it the same way. You just attach the picture, and it's right there. So that's how we're going to kind of do that from this point forward for those. Now, second off is we are not going to do live streams. So that's for a couple of reasons. The last time we did a live stream, and we were trying to do it to where you could see the whiteboard on my iPad, and we could kind of go through that. It's just malfunctioning. The iPad was crashing. I don't know if it's something with the program I'm using. So it's just not allowing us to do what we needed to do. So we'll have videos of the lessons themselves, which is what today's is going to be. We're going to talk about 5.5 in our book, which is the next target. And then you'll have kind of a follow-up on that as far as assignment goes. So in place of the live streams, we are going to have some place that we meet. Live, in person, everybody together. So I will kind of push out some information on that later in the week, probably by this Friday, so you know kind of next week what that's going to look like. It could be through Google Meets, could be through Zoom. We'll talk a little bit more about that, but just someplace where we can all kind of come together in real time and make sure you all have a chance to voice any concerns or voice anything, and just make sure everybody's good. Okay. So look for that coming up. Probably the first one kind of next week, Monday, Tuesday, or whatever. Okay? So where we are moving to is section 5.5 in our book. Basically what that is doing is we're using theorems to factor polynomials. So we're going to be talking about kind of 2 main concepts, which is going to be long division of polynomials and synthetic division of polynomials. We kind of touched on the synthetic division part a little bit earlier. I think it was in the second target of this unit, and we're going to kind of bring that back in today. So today, what that'll look like, I'll just kind of try to keep this to 15-20 minute video, just a really quick lesson over what that target is going to be. Then I'll link those pages and let you have a chance to read through those and look at some examples, and you'll have a follow-up assignment to kind of finish out this week. Okay, so let's jump over to here. So first off, section 5.5 in your book is what you should have looked at today or yesterday, actually. And it's just saying that you can use theorems to factor polynomials. So like we said, we're going to be focused on 2 main things. Then we'll incorporate some theorems into doing that. So the first thing is we are going to be doing polynomial long division. So I know you're thrilled to hear that we're going to be doing long division, and even more thrilled to know that it's with polynomials. But it's not as hard as you may think right off when you're hearing it for the first time. So the first thing that we want to do is understand kind of in the context of what we're doing, what is this going to look like? And what you're going to have is something like example 1 on page 362, which you can reference. You have those pages that I linked yesterday on the Google Classroom post. So what we'll kind of jump over to do, we'll kind of jump over and look at one of the guided practice problems to make sure that you have another one to kind of follow. So 2 different worked out examples. So on page 363, you have 2 guided practice problems. We're just going to look at one of those. And the first one there says that, this is guided practice number 1 on page 363. It says we're taking the polynomial 2x to the 4th plus x cubed plus x, subtract 1. So that's the starting polynomial. And we're wanting to divide that by the polynomial x squared plus 2x minus 1. Okay? So that's the problem. All right? So the first thing we have to understand is how to even set that up. So we all know long division. Okay, what is that going to mean? That means we're going to have this big bar, right? The long division bar. And we got to know which one goes where. Well, what you are dividing by always goes on the outside, and you divide it into what's on the inside. If I was doing something as simple as 16 divided by 4, I would put the 4 on the outside, 16 on the inside, because I'm dividing 4 into 16. If I was doing 30 divided by 40, I would put 40 on the outside and 30 on the inside, because I'm doing 30 divided by 40. So in this example, I'm doing the first polynomial up there, which is 2x to the 4th plus x cubed plus x subtract 1, and I'm dividing it by the other one. So since I'm dividing it by x squared plus 2x minus 1, that polynomial goes on the outside. It's my divisor, what I'm dividing by. Then what you're dividing into is the 2x to the 4th plus x cubed. Now, what you want to notice here is there is no x squared term in that polynomial. So just like synthetic division in target 2, if we have a term that is not present, meaning if it's a 4th degree polynomial, and then we have a 4th degree term, a 3rd degree term, but there's no 2nd degree term, we're going to go ahead and put it in here for reference, and you'll realize why later. And then we finish out with the plus x and the minus 1. So now we have a term represented for every degree part of that polynomial, starting with the highest and moving down to the constant. So now what we're wanting to do is we're wanting to divide that outside polynomial into the inside. So the setup basically looks the same. It's kind of the execution that you want to make sure that you clarify. So the first thing, and this is going to basically apply at every single step, we're just going to repeat this over and over and over, is we are going to divide the term with the highest power, okay, that's left in the dividend, by the first term of the divisor. So the highest term left under the bracket, so the highest degree term right now is 2x to the 4th. So we're going to divide that by the first term of the divisor, which is x squared. All right, so the first thing we're actually going to do is we're going to see 2x to the 4th divided by the x squared. Okay, so that's it. Just those 2 terms are what we're going to look at first. So by dividing that, you can think of a couple different ways. You can literally divide it. So you can set it up, say, over here, and I'll have this in red. So we're doing 2x to the 4th divided by x squared. Well, the quotient of powers property says dividing 2 terms with the same base, you keep the x, subtract the exponent. So 4 subtract 2 is 2. Then, of course, it has to have a 2 because this is a 1, and it's 2x squared. So now we have to think about, okay, where do we put the 2x squared? Well, we put it above the 2nd degree term, and that's why we had to put in this 0x squared. Because since the first quotient that we get is 2x squared, that's where we place it above our bracket. Now, just like basic long division, you divide, you multiply what you got by the divisor, and then you subtract. So now we take this 2x squared and multiply it by all 3 terms of our divisor. So I'm going to do 2x squared times x squared, which is 2x to the 4th. And that's why I want to find that, is because I want to find what multiplies to get me this, because that's going to cancel. Then I have to do 2x squared times 2x, which is 4x to the third. Then I have to do 2x squared times negative 1, which is 2x. Now, I drew this 2x really large, so I'm going to draw that a little smaller. So then that's what we're left with. And those three terms come from multiplying the quotient up there, the 2x squared, by the divisor. Okay? Now, just like any long division problem, I subtract all of that. Okay? 2x to the fourth minus 2x to the fourth is gone. X to the third minus 4x to the third is negative 3x to the third. And then 0 subtract 2x, and that is 2x squared, should be, is negative 2x squared. Okay? So, and that is plus 2x squared, excuse me, because that is 0 subtract negative 2, okay, which essentially makes it positive. So now, the next step, just like in regular long division, is to take the next term over here and bring it down. So now I'm going to bring down the plus x. Do that in a different color because now it's going to start to signal kind of the next step. Because now what I do is I look at my highest degree term, which this time is the negative 3x cubed, and I go ahead and I divide it by my first term, which is my x squared. So now I have to do, going over here to the side, negative 3x squared. That is a negative 3x cubed divided by x squared. Again, I just use my properties and I know that is negative 3x. Just by knowing quotient, powers, property, all that. So it's negative 3x. So up here I put subtract 3x. Now I repeat the process. Since that's negative 3x, I take that negative 3x and I multiply by everything in my divisor. So I do negative 3x times x squared, which is negative 3x to the third. Again, I want that. Then I do negative 3x times 2x, which is negative 6x squared. Then I do negative 3x times negative 1, which makes that a positive 3x. Okay? Then I again subtract these. Those two cancel. 2x squared subtract negative 6x squared is 8x squared. And then 1 subtract 3 is negative 2. Now, just looking at, let's look at one more different color here. So now we take the last term, which is the negative 1. We bring it down and we go through the same process again. Our highest term is 8x squared. So we divide that, the 8x squared, by the original x squared, which is the first term in the divisor. Well, that just gives me 8 because the x squareds cancel. So now this time up here it is plus 8. Now I take that 8 again and multiply it. So 8 times x squared is 8x squared. 8 multiplied by 2x is 16x. And then 8 multiplied by negative 1 is negative 8. I take all of this and I subtract it. Cancels. Negative 2 subtract 16 is negative 18x. Negative 1 subtract negative 8 is positive 7. So, we have a bunch of stuff up here, okay? Now, we know we can stop because there's nothing else to bring down. We brought down everything that we had. So just like in normal long division, that means we're finished. So since we didn't have kind of nothing left, meaning we didn't have a remainder of 0, we have to understand the parts of this. And that means that our quotient is what's above left up there. So our quotient is represented by this up here. That expression, 2x squared plus 3x, subtract 3x plus 8, represents your quotient. Okay? Then the value down here, the negative 18x plus 7, that represents your remainder. Okay, that was what was left over. It didn't divide into it evenly. This up here was your quotient. So I know that's a lot on the screen right now, but you just have to break it down into a series of repetitive processes, taking the highest degree term inside the polynomial you're dividing into, dividing it by the first term in the divisor. Okay, and then you just multiply, subtract, repeat. Divide it, multiply, subtract it, repeat. And then you just do that until you don't have any terms left. And what you'll notice is that the resulting quotient should always be a lesser degree than what the starting polynomial was. The starting polynomial was a fourth degree. Our quotient was a second degree. That makes sense because if you're dividing it, you're breaking it down into a lesser term because you're dividing something out of it. So you have a quotient and you have a remainder. Okay, we'll talk a little bit more about what to do with those two values later, but that's kind of the basis. So for the polynomial long division, you can look at page 362 and there's an example, and then there's a check your or guided practice on 363. There's another example. So you'll kind of get into that today and have some other practice problems that I want you to look at, but I don't want to make this video an hour long like a regular class. So that's the only one we're going to do here. So now let's pull up a new screen here and let's talk about the second thing, which we've already talked about a little bit. So this one should be a little bit little more familiar than doing long division with polynomials, is synthetic division. So in Target 2, you did synthetic division to figure out if a value was a solution or a root to a specific polynomial equation. Here, we're going to actually use synthetic division to actually divide two polynomials. Now, the one thing you want to make note of with synthetic division, you can only do synthetic division, so you can only do it, okay, when the divisor is in the form of x subtract k. So basically, you can't do synthetic division with the last example that we just had because our divisor was x squared plus 2x subtract 1. So it's not in the form of just x subtract k. So synthetic division is a little more basic. It's where you're taking an original polynomial and you're dividing it by something that's like x plus 2 or x minus 5 or x plus 10. Now, the one thing I want to know before we get into the example is that you notice here the form is subtraction, right? So if it's x subtract 2, that actually means k is positive 2. If it's x plus 5, then that means k is negative 5. So kind of that whole point slope thinking that you want to make note of. So a synthetic division example, and again, you have a couple of these in your book. I want to do one that's not worked out in your book for you. So I think this one that we're going to do is on page 364, and this is number 3. Guided practice number 3 on page 364 if you want to reference it and look back. So the problem is telling us we're going to do x cubed plus 4x squared, subtract x, subtract 1. Okay? And we are taking that polynomial and we're dividing it by x plus 3. Okay? So, first thing I want to make note of is if we look right here to the second, the divisor right here, that would mean that k is equal to negative 3. Because since it's addition, we know it has to be in the form of x subtract k. So the only way it's going to be x plus k is if k is negative. So k has to be negative 3. So when we're setting up synthetic division, the first thing that you're going to do is identify what k is. Because that's the first number that we're going to use to apply it and start to work it. So we're going to set this negative 3 out here. and just kind of leave it there for right now. Then if you remember synthetic division from target 2, we have to first list the coefficients in order. So of the dividend, so what you're dividing into. So that is here. So we have to list the coefficients. So the highest term is x cubed. That coefficient is 1. Then the next term is x squared. That coefficient is 4. Next term is just x. That coefficient is -1. The next is your constant, and that's -1. So we just list our coefficients out. Remember that if there wasn't an x squared term, say, on this one, you would put 0 in for that. You have to fill the space for every degree term, even if that degree term is not present in the polynomial equation that's being used as the dividend. So now we get this set up, and we start to bring stuff down. So the first thing we do is bring down your first number, and then we take k and we multiply it. So we take this -3 and we multiply it by this number. So -3 times 1 is -3. Then we add vertically. So 4 plus -3 is 1. Then we just repeat that. -3 times 1 is -3. We add, that's -4. Then we do -3 times -4 is 12. We add, that's 11. Okay, so multiply, add, multiply, add, multiply, add. Once you get it set up, you just repeat, again, that same process. Now, this is kind of where we were at in target 2, is we would find that, oh, the answer is 11. So when you substitute in -3 into the original polynomial equation, you get 11. But with this target, we're focused on actually dividing these polynomials and getting tangible expressions that are polynomial expressions as the answers. So we have to understand the parts of it. So first thing is the last number is always your remainder. So when we divide these two, it has a remainder of 11. Then we look at what the highest power of the dividend is. The highest power is 3. So that means if we're dividing it with synthetic division, the first term is going to have a power of 2. So the first one here, coefficient of 1, that means it's going to be 1x to the second. Then we just go in order. It's +1 here, and that's going to be plus 1x to the first. Then it's subtract 4 here. That's going to be x to the 0 or just 1. So it's going to be left like that. So to kind of finalize our answer here, if we were to write that here, our final answer is going to be x squared, subtract or add x squared plus x, subtract 4 with a remainder of 11. That's our actual answer for this. When we get that quotient, that is going to be what it is when it's divided into. Then we have a remainder, which is what is left over. So now, and this is on pages 363 and 364 in your book, it talks about two theorems. It talks about the remainder theorem and the factor theorem. Now, those theorems aren't that important in the sense of you don't really have to do anything extra. If you can do the long division and the synthetic division, then you're golden. The remainder theorem just says, well, the remainder is just going to be the same as plugging it in when you're doing synthetic division. Well, okay, that's kind of common sense. The factor theorem says it's a factor if it doesn't have a remainder. Well, that kind of makes sense too. If the remainder is 0, well, then it's a factor of the polynomial. If the remainder is not 0, it's not a factor. So we're not going to worry as much about those two theorems with this target. The biggest thing we want to be able to do is do long division and do synthetic division. So what I would do is just kind of be able to work through some of those examples that are long division with polynomials and synthetic division with polynomials. We're at roughly 23, 24 minutes on the video, so I'm not going to kind of go through 2 or 3 more examples on here because, again, it would be 45, 50 minutes. So just watch through this video, and here's what I want you to do. So this is going to kind of be your proof that you watched the video and you did kind of go through and take your time and watch it. So at the end of this video, which is going to end here in just a few seconds, I want you to comment down below. I want you to go ahead and put your name on the comments because some people's YouTube IDs or usernames are just crazy stuff, and that's fine. It don't have, I mean, it's your YouTube name, but go ahead and comment your name and just make a comment about something in the video. You can either ask a question or something that was clarified to you. You can say, "Hey, Mr. Cox, this is me. This is Matthew." And it really helped knowing that you have to include all the terms even if it's not present. Boom, you're done. Or, "Hey, Mr. Cox, this is Matthew. I still have trouble about how to order the long division polynomials." Okay, we'll reference that and we'll go that. But everybody has to make a comment, whether it's just a basic observation about the video or a specific question that you might have. Then I can kind of reach out and touch base with those that have specific questions, or if it's 5 or 6, 7 different people have the same question, then we may do a follow-up video later in the week to clarify that. But that is how you're going to become engaged in the video. So make sure that you comment in that way. Okay? That's how you're going to get credit for being a part of this video versus a live stream where I know that you're here. So go ahead and make your comment. Again, you have to be logged into YouTube to make a comment. It does not take more than probably 30 seconds to a minute to make a YouTube account if you don't have one. You can even use your school email, your Gmail account, to make a YouTube account to be able to comment. So if you have any issues, just shoot me an email or shoot me a message on Google Classroom, and we'll definitely get it worked out. Like I said, it's a work in progress. So I'm learning as you all are learning how to do this remotely. I know it's hard and it's uncharted territory, but we will do our best to continue to try to kind of shape what we're doing to be what is best for you all to try to move as far forward as we can. Okay? So I'm out. That is it for this video. Make sure you do your comment and let me know if you have any other specific questions. See you guys.